Hello, Chem 107 Lab. I hope you all are having a good week and had a good weekend. We're going to do electrolytes and conductivities today. So first, let me find a blank spot in this lab report and read through all this pre-lab material. It will definitely help you out. I'm just going to go over a few things. I'm just going to go ahead and start writing right here. First off, I assume you guys have learned about electrolytes, but I just want to go over them because they're important for this lab. It's what this lab is about. So electrolytes come in three flavors, as I like to say. The first, and we can start anywhere, but let's start with strong electrolytes. And you guys are probably familiar with electrolytes. I know you probably, when you work out, you probably drink Gatorade or something like that. It has electrolytes in it. Basically, those are just salts that have been added to Gatorade to help replenish the salt you lose when you sweat. And it's called Gatorade, of course, because University of Florida Gators. Apparently it gets pretty hot in Florida. Anyway, strong electrolytes. These conduct electricity strongly. Or we could say they're good conductors. Doesn't really matter how you want to say it. But something maybe I should back up and mention, pure water will not conduct electricity, okay? If you have 100% pure water, and that's maybe kind of important for this lab, it will not conduct electricity because it's a molecular compound. So when we always hear about, don't blow dry your hair in the bathtub, I don't know who would ever do that. What's the point? Obviously, I don't blow dry my hair. Anyway, the reason is in your bathtub, it's not pure water. There are electrolytes dissolved in that water, and they are what conduct electricity. It's actually the ions in a solution that conduct electricity. So we have to have ions to conduct electricity. So strong electrolytes yield, I'll just put it this way, lots of ions in solution. So strong electrolytes give you lots of ions, and they come in a few different classes. So let me tell you what are strong electrolytes. First of all, we have strong acids, strong bases, and there's a list of strong acids and strong bases in the lab manual. It's on page 139, so you can just go ahead and look at that. And then soluble ionic compounds. Soluble ionic compounds. Okay, let me just make a note here. You want to look at the solubility rules. It doesn't matter which ones you use. They're on page 55 in the lab manual. But you have to know if an ionic compound is soluble. So you can use whatever solubility rules you want, whichever ones you use in class are fine. Okay, strong acids, strong bases, and soluble ionic compounds are strong electrolytes. Just an example, if we have HCl aqueous, that will dissociate to give us H plus aqueous plus Cl minus aqueous, okay? Whoops. Now, that doesn't tell us how much of each one there is, but for HCl, it's a strong acid. It is one of the 6 strong acids. So we basically have 100% this. Whoa, that's wrong. Sorry about that. I meant 0% this and 100% this. Basically, what that means is HCl does not stay HCl. It breaks down into H plus, this H plus, and then the Cl minus here. Okay, that's complete dissociation. Next up, we have, let me find another blank page. We have weak electrolytes. Weak electrolytes. These are poor conductors. Of electricity. Why? Because they have few ions in solution. Okay, and the type of compounds we're dealing with here, this is real complicated. Okay, we had strong acids before, so now we have weak acids, weak bases, and we had soluble compounds, ionic compounds. Here we have insoluble. Again, use the solubility rules to figure that out. Something is insoluble, well then it's not going to conduct electricity very well. But it might conduct it a little bit, and the reason is, if we look at something like, let's look at acetic acid this time. HC2H3O2. If this is aqueous, we have now what we call an equilibrium, and I'm going to draw two arrows. Excuse me. A tiny forward arrow and a big backward arrow, and I'll explain that in a second. That's equilibrium, which you'll get to in this class. And this breaks up into acetate and H+. Now we have a totally different situation. What we have here, this is about 99%, and I'm just approximating. And this is about 1%. It's probably even less than 1%. But what that means is, in solution, we really have this. We don't really have many of these ions, okay? It's just what we call the molecular form, which is the form on the left. The form on the right, we do not have very much of. Because of that, there's not very many ions in solution, and we don't have a lot of conduction of electricity. Okay, last type of electrolyte, we did weak, strong, weak, and now we have non-electrolytes. You might figure out that these do not conduct electricity. There we go. There are no ions in solution. And how are we going to recognize these compounds? These are molecular compounds. Remember, molecular compounds are made up of non-metals only. Okay, so an example of that, in your blood, you all have glucose. C6H12O6. If we take some solid glucose and we dissolve it in water, I'm just going to say we're adding it to water there, we will get C6H12O6, aqueous, no ions, okay? So it will not conduct electricity, but it will dissolve. All right, let's go through this lab real quick, highlight a few things. There's a slideshow with pictures of all of these things except for the deionized water, but I explain that one to you. All right, so note here, under deionized water and tap water, for this one we're comparing deionized water and tap water together. That's how this whole lab is set up, so you're comparing a couple or three things together. So all you got to do, circle your choices. Is it a molecular or ionic compound? Is it a solid or a liquid? These are meant to be easy. Let's see, what kind of electrolyte? Just answer the questions. How does that explain the conductivity behavior of deionized water? Well, this means if it is molecular, let's find a different pen. If it's molecular, hint, hint, and it's a liquid, and it's a non-electrolyte, are there ions? That's how you answer this, okay? Molecular, liquid, non-electrolyte. You have to tell me there are ions or not ions in solution. There's a few ions, there's a little bit of ions, or I'm sorry, many ions, something like that, okay? And same thing for tap water. And that's how all of this is going to go. basically explaining if they're ions in solution or not. And here, I'm going to tell you one thing, molten. Molten means melted. I'm just going to post a video. I was going to say go to YouTube. I'll post a video of molten NaCl so you can see what happens. All right, I'm going to try and wrap this up because it's getting long. Nobody wants to listen to me all morning. Okay, glacial acetic acid. There's no water in glacial acetic acid. Absolutely no water. Is 100% pure acetic acid, molecular compound. Okay. The 1 molar means there is water. It's dissolved in water. So just go through and answer the questions. There's a couple more things I wanted to point out. Oh, these two look very similar. Both bright. They should not be both the same. So use your common sense, and maybe the pre-lab discussion that I wrote out will give you a hint as to how to answer that, whether it's a good conductor, poor conductor, or non-conductor. Okay. Same goes for these two. They look very similar. However, one is a strong base, one is a weak base. So use that information to answer the questions. These are all ionic compounds. Okay. The NH4 is a cation. Okay, NH4 plus. Remember that. Ammonium. And another hint: these are all highly soluble. Okay, there's glucose. I already explained glucose. C6H12O6. Barium sulfate in water. What you cannot see in the video is that this jar has a white solid at the bottom. So what does that mean about barium sulfate? Is it soluble or insoluble? Well, if it's a solid, that means it is insoluble. Okay, use that to answer those questions. And here, this one is probably the trickiest. We're mixing barium chloride and sodium sulfate. I'm going to write these out because I'm not there to look over your shoulder and help you out. Okay, and what you cannot see is the jar containing the mixture. It also contains a white solid. And I'll give you another hint. That white solid, when we combine barium chloride and sodium sulfate, oh, guess what? There it is. Okay, it's a precipitation reaction going on in this mixture. So use that information to answer these questions. You're going to have to write out an equation and explain the conductivity behavior of the mixture. Let me give you a hint here. Spectator ions, but you got to tell me what they are, okay? And I think you got the rest of it. I hope you guys have a great week, and hope you all are doing well. I wish we could be in class together, but oh well. Take care.